The valve fits very well down in the engine block into what I call the valve body. So I'm going to drill it for a wrist pin. That's a through hole through the end of the lower end of the body of the valve, a 1/16 inch diameter through hole, and then I'm going to slit it with a .057 inch thick slitting saw for the eccentric follower length to move. And the slitting process will remove the burr created by drilling. Then I'll have to remove the burr created by slitting in some fashion. Might stick it back in the lathe and touch it with a file. But removing that burr is a lot easier than removing the inside burr that would be caused by drilling if I slit it first and drill it second. So here we go. That doesn't seem like a very sharp center drill, so I'm going to swap it out. There we go, that's a lot better. Don't need much center hole to start a 1/16 inch bit, so that's good. I've inserted the drill bit, and now I'm going to drill the 1/16 inch through hole. Looks like I need to pull that drill bit out a little bit or lower the table or something. I lowered the table and pulled the bit out so I can drill the hole without the drill chucks, without the chuck keys hitting the vise. There we go. I'm ready to slit the valve for the eccentric follower link to fit up in there. I've already drilled the through hole for the wrist pin. Got to be very careful doing this because, as you can see, I'm not holding the valve by very much. I'm just holding it by the head and a little bit of the tail end there. So I'm going to take really light cuts and keep my fingers crossed. A better order of operations, and I've done it before but I simply forgot this time, is to drill the wrist pin hole and slit the valve before any lathe work is done. In other words, on the raw stock, and then do the lathe work. However, if one does that, you lose the ability to put to hold the tail end of the valve in the lathe with a center. So maybe it's 6 of one, half a dozen another. We'll find out. If this holds, then this was the best way. If it doesn't, then it wasn't. going to touch it so I'll know where my zero is. In fact, what I'll do is touch off a piece of telephone paper. Telephone book paper. Remembering not to hold that piece of paper very tightly, so if it jerks, it doesn't pull my hand into the saw. That would be uncomfortable. There, it's touching. So I'll clamp right there for a moment. Take a 10/1000 inch cut on the way to I'll have to look at the drawing. On the way to 250 thousandths. Guess I forgot to dial in 10/1000. That always helps. Helps to turn the table the right direction too. There's the valve. Got a nice slit in it. And the slit is 57 thousandths of an inch, and there's no burr in there from drilling that wrist pin hole. If there was, I wouldn't be able to do this because this material is 52.5 thousandths, I believe, so pretty close. So here is this little hole right here, not the big one. The little hole is the hole for the wrist pin, and as you can see, the follower link is a little bit long. I'll take it down and shape it and form it in such a way that I get rid of all this material on the end of it, and it'll make a nice fit in there. I'll press that wrist pin. And it'll wind up looking like this one. It goes on a different engine. All the parts are finished. The final thing I need to do is assemble the eccentric follower link to the valve. I'll use this 1/16 inch pin that I'm pointing to press. I'll press it through the valve and through this wrist pin hole, and then I'll trim the pin up with the belt grinder, belt sander, I mean. And then this engine's ready to run again. I've this valve seals a whole bunch better than that previous valve did. We already know the engine runs. I want to make it run a lot better than it did. Previously it took about 8 pounds of pressure. I'd like to get it down below 5. Well, I'd love to get it at 2. We'll see. This valve seals real well. Alright, it's time to put this baby together. Here's the assembled valve, centric follower link. A little stiff, but it'll loosen up. Before you put anything together, you need to oil everything. Start with that, see if it'll make it a little, that's a little easier. You can't over oil these engines. I'm convinced I could set one in a bucket of oil overnight and then crank it up next morning. Other than making a huge mess, it would run. A couple more things I need to do to it. I need to build a base here, and I will. This set screw will go in flush, and I will Loctite it in place. So I'll put this thing together and then time it off camera. Put that backwards. Well, I'll fumble around and put it together. When I bored this engine block, I had it clamped in the vise like this. Unfortunately, this 1/2 inch by 1 inch upright was not enough to keep it from chattering. The finish wasn't so bad, but the bore was egg-shaped and kind of tapered. So the seal on the piston was poor at best. You saw it running earlier at 8 pounds a square inch. In my efforts to make it run better, I rebored re-reamed the cylinder, the valve body out to 0.261. Got it and built a new valve and fit real well. And then I decided to rebore the cylinder. But doing it like this didn't make any sense. I'd already done that and failed. So what I did was sandwiched it between these two pieces of steel, about a, oh, I don't know what they are, 3/8 inch, and clamped it thusly and rebored it, and it turned out real well. So the moral of that story is, don't do what I did. Even this, what I would have thought would have been thick enough and wide enough this way, piece of aluminum, wasn't enough to keep it from chattering way up, when you extend it above the vice jaws that much. However, I've bored these blocks in the past prior to forming the upright. In other words, when it was just a 2-inch by 1-inch rectangle of aluminum. I've successfully done that. But that's a lot more meat to prevent it from chattering. So anyway, I'm happy with the bore now, and we'll proceed. This is going to be in the piston. It's a piece of 4140. It's 7/8 inch in diameter. I'm going to take it down to 0.5937, or actually I'm going to take it down to fit this bore, whatever that is. Best I can tell is 0.5937. I measured it with telescoping gauge. So I'm going to face this first, and then I will give myself an undercut at about half an inch, and then I'll take it down to a diameter. Now I'll power feed it, get a good finish on it. Turn it at about 7/8 inch. At 7/8 of an inch diameter, I'm turning it at 120 SFM. Of course, as facing cut diameter gets smaller and smaller, the surface feet per minute decreases. This is going to work. So I'll bring you back when there's something significant going on. This relief cut, which I've cut down to a diameter of I've taken it down 200 thousandths, 400 thousandths, forgive me, will give me plenty of stress-free turning of this diameter down to 0.59, whatever I said a while ago. It's going along okay. I'm not tremendously happy with the finish. So I'm experimenting with different feeds and speeds. I may either change inserts or go to a tool that I ground. Now's the time to figure it out because I've got a long way to go. That was a 20,000th inch cut. See what that looks like. That would work. That would work fine, but maybe I can get a little better. I played around with my own tool, a larger radius. That seems to be doing the trick. I'm turning it at 133 FFM now. A little fast maybe for this 4140 with high-speed steel. Guess I ought to take some off. About 20,000. See what that looks like. Okay, that looks better. About all I can say. Alright, I don't know how good I am with those telescoping gauges, but I measured the diameter of this bore at 0.5937. And I snuck up on the diameter of my piston and till it fit, basically. There's a nice fit. And I mic'd it, it's 0.5916. So it's within, well, you do the math. It's close. I'm going to get you caught up here. I've got the piston mounted in the curt, and I've already drilled the wrist pin hole, an 1/8 inch diameter hole through it, and I'm about ready to slit it 57 thousandths of an inch for the connecting rod, which will be made out of the same material as the eccentric follower link, of course. Notice that the V-block holding the pistons off on this side of the vise, but inside here, I believe you can see this, I've got a screw jack at the same distance, extended to the same length as this assembly, so my vise doesn't cocky wobble on me. So that's about it. I'm going to I'm going to slit that piece of 4140 to a total depth of 0.350. Alright, turned out well. Got a nice slit for the connecting rod, through hole for the wrist pin. I'll stick it back in the lathe and clean up this burr right here. The wrist pin on one end of the side of the wrist pin hole, and this burr right here where the slitting saw exited. And I'll chop it off at 1/2 inch. Piston will be 1/2 inch long. Alright, here's the new piston. It fits in the cylinder very well. When you make this, after you slit it, it will release stress in the metal and it'll expand a little bit. Can't tell you how much because I don't know. It's just a tiny bit. You can look it up in tables. To get it to resume, not to resume its shape, but to get it back down to proper diameter, you've can use wet dry sandpaper. I use 200 grit on it. Now it fits in the bore really well. I'm happy with it. I'm going to use this connecting rod since it's already built. Kind of hate to take the piston off, but the chances of reusing this piston are pretty slim. So I'll press that pin out, stick this connecting rod in here, and stick another pin through it. There's the difference in the bores, diameter of the pistons. New piston on the existing connecting rod. I've got it put together, except for the head, of course. I'll show you how it moves. It's got a weird tight spot, not a tight spot, but every once in a while it comes around in this direction and I can feel a tight spot or a hesitation or something. But that'll wear out almost immediately. You can see the piston and the valve working. You can see where the valve goes down below the inner valve cylinder hole. Not a lot. I wish it'd go down. I should have made it the connecting rod a little bit shorter maybe, but I think that'll work. You don't need much of a inner cylinder port there, inner valve cylinder port. You don't need much of one. I think that'll work. So we'll put the head on it, see what happens. Running about something less than 2 pounds. Whoop, stopped. Bragged too early. We'll give it a little more juice. I'm confident when it breaks in, when it gets broken in, it's going to run at 2 pounds or less. There's, I'd say that's just over 2 pounds. Let's lower down a little bit. I'd call that 2 pounds. A little less than 3 pounds if you average out the swings on the needle. That's about 3 pounds. So I need to build the base for it. Just can't give my Kurt away for a base. There it is, running on about 1.75 pounds maybe. It's finished. I built this one for my grandson, one of my grandsons. I haven't seen in a long time. I hope he likes it. I guess it's not quite finished. I need to screw that in a little bit, Loctite it in place. So that I'll screw it in such that it's flush with the surface of the engine block. But it's finished. This makes me happy.